For this example, we've got a couple of functions given, several given in A, B, C, and D. And in each case, we want to first identify whether or not it is a polynomial, and then if so, identify the leading term, degree, leading coefficient, and the constant term of the polynomial. So let's start with A, where we've got a function f of x, which is equal to 7x minus 8x to the fourth. And so when we say leading term, this doesn't mean the term that comes first. It means the term that has the highest power of x. And so if it's not given in this form, we should rearrange it so that the powers of x are in decreasing order. So I start with the largest one. And first of all, this is a polynomial. All of these terms with x have non-negative integer power. So the leading term here is the minus 8x to the fourth. And the degree is the largest power of x that we see. So in other words, we have x to the fourth in the leading term, so the degree here is 4. The leading coefficient is the coefficient in the leading term. Which is minus 8. So we need to include the negative sign. And the constant term is 0. Since we don't have any constant term, we could think about having a plus 0 over here. So those are the degree, leading coefficient, and constant term for A. In part B, we have g of t is equal to 2t to the fourth minus t to the 1/2 plus 5. And here we've got a problem. This 1/2 is not an integer. And polynomials have only non-negative integer powers of the variable. So this is not a function. It's not a polynomial. It is a function, it's just not a polynomial function. For C and D, we'll move over to another slide since we need some more space. For part C, we have a function which is given as a product of a couple of expressions. So we have 2z minus 5 times z squared plus 4. So before we identify the leading term and the constant term, let's write this polynomial out in its standard form. Let's distribute these terms and group them together. So I can take 2z minus 5 times z squared and then add that to 2z minus 5 times 4. And so when I multiply this piece together, we get 2z cubed minus 5z squared. When I multiply these, I get 8z minus 20. And so now we've got this polynomial in standard form. The term with the highest power, I've just circled in green, so this is the leading term. The constant term is over here. And so from the leading term, we see that the degree is 3. The leading coefficient is positive 2, and the constant term is minus 20. So we need to include the minus sign. And now for part D, here we've got similar as part C, we've got the polynomial, which is written as a product of a couple of different terms. So before we begin, let's first expand this 3x minus 5 squared term, this factor. And so distributing this out, we would get 9x squared minus 30x plus 25, right? So we would need to distribute this out and collect our like terms. And so now this function g of x is equal to 9x squared minus 30x plus 25 times x plus 1 times x minus 4. And so now let's make the following observation, that this is a polynomial. This first factor is a polynomial because x occurs to integer powers that are not negative. And the same goes for this factor and this factor. So when we multiply three polynomials, the result is going to be a polynomial because we're just going to be adding powers of x that are already positive integers. So this is a polynomial. And in order to find the degree and the constant term, what we can notice is I'm going to circle the leading term in each of these parts. And so where would I get the term that has the largest power of x? Well, I would take the largest power of x in this piece, multiply it by the largest power of x in this piece, and multiply it by the largest power of x in the last piece. So the leading term is going to be the product of the leading terms. So it's going to be the 9x squared times x, which would give us altogether 9x to the fourth. So there's our leading term, from which we can see the degree is 4, and the leading coefficient is 9. And the constant term I would get only when I multiply terms that don't have an x in it. So in other words, the product of the constant terms that I've just boxed in black. So if I were to take any term that has a power of x, I'm going to wind up with a non-constant term. So the constant term is going to be the product of the constant terms, which in this case would be the 25 times the 1 times the minus 4, which gives us minus 100. And again, this is a nice way to do it. I didn't actually have to distribute out this entire thing and group all of my like terms. That would take up a bit more time. I just need to notice that the leading term I get by multiplying the three leading terms, and the constant term I get by multiplying the constant terms in each of these factors.